In the previous video, we looked at the use of k-means algorithm to cluster our data. In this video, we're going to use vector quantization to compress an image. One of the main applications of k-means clustering is vector quantization. Simply speaking, vector quantization is the n-dimensional version of rounding off. When we deal with 1D data, such as numbers, we use the rounding off technique to reduce the memory needed to store that value. For example, instead of storing 23.734.73572, we just store 23.73. If we want to be accurate up to the second decimal place. Or we can just store 24 if we don't care about decimal places. It depends on our needs and the trade-off that we are willing to make. Similarly, when we extend this concept to n-dimensional data, it becomes vector quantization. Of course, there are more nuances to it. You can learn more about it at www.data-compression.com. Vector quantization is popularly used in image compression, where we store each pixel using fewer bits than the original image to achieve compression. So let's see how we can achieve it in Python. The full code for this video is given in the vectorquantization.py file already provided to us, which we're using here. Let's look at how it's built. We'll start by importing the required packages. Now create a new Python file and add these lines of code. So these are the packages we need to import in our file. Next, let's create a function to pass the input arguments. We'll be able to pass the image and the number of bits per pixel as input arguments. Then create a function to compress the input image. Once we compress the image, we need to see how it affects the quality. Let's define a function to plot the output image. We're now ready to use all these functions. We define here the main function that takes the input arguments, processes them, and extracts the output image. Next, we load the input image, and then we print the original image. Then we compress this image using the input argument. We're now ready to run the code. So, let's go to the command prompt and run the code. We're using a flower image provided to us. So the size of the image will be reduced by a factor of 2, and the compression rate here is 50%. Here we have two images in output. The left one is the original image, while the right one is the compressed image. You can clearly see the difference between both. Let's now compress the image further by reducing the number of bits to 2. So we just make a minor change in our command and make the number of bits from 4 to 2, and then run the command. Again, we have two images on our screen. One is the original, while the second is the compressed one. Now the compression rate has changed to 75%, which was earlier 50%. Let's see what happens if we reduce the number of bits to 1. So we make the change in our command and run it again. You can now see that it becomes a binary image with black and white as the only two colours. Amazing! In this video, we compressed an image with different parameters to attain different outputs. In the next video, we'll build a mean shift clustering model.